Okay, we're back. When we're talking about the first thing we want to look at this is two triangles, because the circle there's no all circles are similar to each other, right?
Yeah.
One another, just proportional. There's some bigger ones, smaller ones, all similar. But anyway, forget about that comment I made. Triangles are either the same or for instance, two triangle. There's one triangle. They just say that these two triangles they look similar, right?
Mm-hmm.
They're similar. Similar means this angle equals to this angle equals to this angle, and this angle equal to this angle.
Yeah.
The side may not be equal, but when the sides are not equal, they're proportional.
Mm-hmm.
Call this alpha, beta, gamma. This is A, this is B, this is C. This is A1. Call this 1. This is A2, B sub 2, C sub 2. Okay, or 2. Okay. You have this. Okay.
Yeah.
This is similar because this thing can be flipped. It doesn't really matter. But when they're equal, there's a word for it. They're called congruent.
Yes.
Congruent is done. For instance, this is A, B, A, B, C, right? A1, B1, C1. The capital letter indicate the points, and the small letter indicate the side. This is A1, A2. This is A2, B2, C2. Okay.
Mm-hmm.
So we say triangle A1, B, ABC, 1, 1, 1 is for these two, right? We call it A. Okay, for these two triangles, they're not congruent. Obviously, they're similar, but this is the way that you do it. And for angle, for instance, this alpha is say 30 degrees. I think in the standard writing is that this is call this alpha 1, beta 1, gamma 1. This is alpha 2, beta 2, gamma 2.
Mm-hmm.
When you write this up in angle, you don't say alpha 1 equals to alpha 2. You say alpha 1, the angle alpha 1 is congruent to alpha 2.
Yeah.
However, the measurement of alpha 1 is equal to measurement of alpha 2, which is 30 degrees.
Okay.
This is the way of writing. I got that from your textbook.
Cool.
You just
Yeah, I can see.
yeah. Okay. Now, what we want to take a look is what determines a triangle, the shape of a triangle. Okay.
Mm-hmm.
Now you have a triangle. You have a triangle. This is alpha, beta, gamma. This is A, B, C. What determines its shape?
3 sides, 3 angles, and those are equal to 180.
Yeah. But the least amount of things to decide the shape of it, which means similar.
Mm-hmm.
When you want the two, what determine essentially if you have two triangles, how do you determine it is similar? Of course, if those three angles are all the same and then 3 sides are all proportional, they are similar, right? But you don't need all of them to be to exist, right? You don't need to know all 6 of those things, right? So what do you need to know? The least amount of things you need to know to say these two triangles are similar.
They're proportional.
Well, then what? Sides, right?
Yeah. And
How many sides do you need proportional to say that?
2, 3, 2.
What's the difference between 2 and 3? Just look at it.
No.
If you know two sides are proportional and the other side you don't know, that means this angle can come down, up and down. The other two are, let's just say the same, right?
But if you know the other, okay.
In other words, if you let's not talk about proportional because equal is the same as proportional, right? You know one triangle like this, right? The other triangle, let's say this point is here, right? Is like triangle like that. This side is equal to this side, and this side, of course, equal to this side. Does that make those two triangles the same? Congruent.
If those C and B are equal.
Yeah, you're talking about two sides, right? If two sides are equal. No, right? You need the other side, right?
Yeah.
However, if your three sides all know, this triangle is fixed.
As congruent?
That's congruent, yeah.
No.
Or similar. What?
Oh yeah, similar.
Similar means they're all proportional. Let's say the other one is the other triangle is half of this. Half of this length.
Yeah. I think.
Yeah. Similar and congruent is exactly the same thing. The only thing is for similar, the sides is proportional. For congruent, the sides is the same. So we talk about congruent, the easier. Right? When you talk about half, you just talk about the same, right? You have two triangles, right? If one side is equal to B, you lay it on B, right?
Yeah.
And then the other one is C, right? If A is different, it's possible, right? The other C is like this, right? Then A is like that. That still make a triangle. You see what I'm saying?
Yeah.
Yeah. Then those two are not equal, are not congruent. So for side relations, you need all three sides, right? We call that side. That determines whether two triangles are congruent, right? Two sides wouldn't do it.
Yeah.
Okay. What else? What else do you need to know? Is there any other way that you can know?
Angle.
Okay. Let's say you know what? Let's start with one angle.
Yeah.
Okay.
No.
Can you do only know one angle? You don't know these two angles, right?
Yeah.
Because you know two angles, basically you know all three. Yeah. They're 180 degrees. So you know this angle. You don't know these two.
Yeah.
But then you need to know some sides, right? Which side do you need to know?
C and B.
Say you know C and you B, right? You have an angle, then you fix the C, then there's that dot is definitely there, right? Then you fix the B, that dot is definitely there, right? You connect the two, it's gonna always come out the same way, so that'll work. The side angle side, right? Side angle side. What's the other way? Let's say you know two angles, right?
Yeah.
Can that work?
No.
If you know two angle, you know the two triangle is similar. Okay. How do you make the similar triangle the same? If you know one side is equal, then all the other two sides gotta be equal, right?
Yeah. If there's. Yeah.
So in other words, you just need to know one side. If you know two angles, right? You just know one side. Or angle, side, angle. You know this angle, you know this side, that works, right? This angle, this side works. This angle, this side, this angle works. No? Just look at this. How about ASS? Does this work? If you know the angle, this angle this angle is equal, and this side is equal, this side is also equal. Does that work?
No.
Why?
Because this thing can move.
Move which one?
Like, you can move left or right. Cause if you know, like,
Okay.
that,
Yeah.
whatever.
Right. You know alpha, you know C, and you know A.
Yeah.
This does not settle this triangle, right?
Yeah.
Because you can swing this A over, and you can swing this A over to this
Yeah.
side. This is A. These two triangles,
No.
yeah, they are same as ASS.
Yeah.
Yeah. This is congruent. This is how. Okay, this one you cannot. Okay, this is how you prove two triangles are congruent. You need three conditions. You need three things to do this.
Mm-hmm.
You know, for similarity, you need two.
The second one and the last one is the same.
No. The second one is side angle side.
Oh, okay.
Last one is
Never mind. Yes,
angle
I
side
understand.
side.
I understand.
Yeah. You don't know this side. If A is this side, then it's fixed.
Mm-hmm.
You cannot change it. It's only the A is the dangling one without the angle. You have no restriction of angle on this A.
Mm-hmm.
The A can dangle over in this side and then still make it.
Yeah.
Yeah, make this alpha, and those are not determined. However, this is determined. There are only two possibilities. Although from ASS, right, you cannot say they're congruent, but they're very much determined. Two possibilities, right? If you know that possibility is not possible, you can still say that's congruent. The two triangles. Okay. For instance, if you know this angle is a right angle. If you know that, actually, if you know this angle is a right angle, let me see. Yeah, if you know this angle is a right angle, you give one side, it'll work.
Yeah.
Because there's no way for this to go. The other way to go is on this side, which doesn't matter. Make the same. It's the same shape anyway.
Mm-hmm.
Yeah. There are exceptions to this. ASS, if A is 90 degrees or right angle,
Mm-hmm.
that'll work.
Okay.
It's not always not working. Okay. In geometry, there are many things that okay, there's several things, but let's not deal with several things. That's one thing at a time. One thing you normally need to do, introduce, is this kind of a proving things.
Mm-hmm.
Okay, we're gonna prove a series of things as an example of how this will work. Okay. First, we're gonna prove this for a triangle. For a triangle, right? If we put it, I need to draw this somewhere reasonable. This is, we make the middle point here, right?
Yeah.
And I connect these two. Connect this point to this point. And connect it. And make the middle point here. If I make middle point on all three sides, and I draw these lines,
Yeah.
these three lines meet at the same point.
Mm-hmm.
Yeah?
Yeah.
Does that look normal to you? Do you think that's right or wrong?
That's right.
Why?
Because it just seems right.
Okay. We're gonna try to prove it, okay?
Okay.
In order to prove it, let's just give it some okay. We're gonna draw a line here. Connect these two lines. We'll call this E, F, G. We'll call this point O.
Mm-hmm.
Yeah. It's very hard to prove that the three dots, the three lines meet at the same place.
Yeah.
So instead of doing that, we'll just say this part, BE equals to EA. This distance is equal.
Mm-hmm.
This distance is equal.
Yeah.
Then these two lines meet somewhere, and I draw a line down, right? I'm going to prove this equals to this.
Okay.
In other words, if this is always equal to this, then of course you draw a line that'll meet here. You see this? I'm not proving. When they ask me to prove something, I'm not proving it. I'm trying to prove something else.
Oh.
To prove three lines meet at the same point is very hard.
Yeah.
So I'm just going to prove two lines the way it is. The other line, well, I'm going to draw the third line.
Mm-hmm.
And the third line going through that point. The third line, I draw the third line through that point is the line that you want. In other words, this line separate. I'm going to prove this line separate these two.
Yeah.
Okay. We're going to use that what we just said. SAS. Okay. Look at this. Look at this triangle and this triangle. Okay. A, E, F, and triangle ABC. Right?
Mm-hmm.
This is 1, then this is 2, right?
Yeah.
If this is the 1, this is 2, because they're equal.
Yeah.
Right? And this angle is the same. In other words, these two triangles are similar.
Okay. Yeah.
Right? Similar triangle, this angle equals to this angle, because that's one of the angles in the triangle, right?
Yeah.
If this angle equals to this angle, this line EF and line BC, what's the relation between line EF and line BC?
They're parallel.
They're parallel. Okay. Now, if they're parallel, we can get several things,
Mm-hmm.
right? If they're parallel, let's see. We know that AEF is similar to ABC, right?
Yeah.
Let's look at the two other triangles. OEF, and OCB.
Yeah.
Are they similar?
Yeah. Wait.
Yeah. Actually, I think I need another point in here. Let's call this D. Yeah. OEF and OCB. Are they similar? Actually, I'm doing it wrong. OEF and OBC.
Yeah.
OCB. Are they similar?
Possibly.
Okay. Well, you need two angles, right?
Yeah.
Do you have the two angle?
You have the one next to each other. The O with the one and O.
Which one?
Listen. No, they're equal.
Which one?
The single and the single.
Oh, okay, okay. So that's angle, say EOF, right?
Mm-hmm.
Angle EOF and angle what?
OBC.
No. OBC. OBC is this angle. OBC is this angle. Which one are you talking about?
This one.
Okay, how do you call it?
BOC.
BOC. Okay, these two angles are congruent. The measurement is equal. Okay, and another angle. Can you get another angle?
BGC. And
BG. No, we're talking about this triangle, right?
Yeah.
And this triangle.
Yeah.
You BGC.
Okay,
BGC,
never mind,
that's the same
stupid.
line.
I know.
Okay, yeah. Is there any other angle between this triangle and this triangle? The same.
No.
What about this angle and this angle?
What about them?
Are they equal?
Yeah,
Why?
because they're on one straight line.
Parallel line.
Yeah. Yeah, I know you showed it.
That's the postulate.
Yep.
Inside angles, I would call it. They are the same, right?
Yeah.
That's, if you write it, that'll be BFE, right? BFE is congruent to BFE then FBC, right? Right?
Yeah.
So these two are similar.
Okay.
And because this is half of this, so what we're talking about is essentially this is half of this, the sides.
Yeah.
This is half, and then everything else is half. This is half, this is half, everything is half.
Mm-hmm.
Yeah? In other words, OC divided by EO, this divided by this is 2 to 1. The other way is also BO divided by FO, right? 2 to 1.
Mm-hmm.
Because BC divided by EF is equals to BC divided by EF, right?
Mm-hmm.
We know this because of this one. These are similar.
Yeah.
Did you get it?
Yeah.
Okay. Did you get? Let me just write it up anyway. We know AB divided by AE, right? Is 2 to 1, right?
Mm-hmm.
So BC divided by BC divided by EF is also 2 to 1.
Yeah.
This just another side, right?
Mm-hmm.
Okay. Now, for the same reason, the triangle DFO and triangle OBG, they're similar, right? Because this angle is the same, right? Oh, they're opposing, and this angle equal to this angle.
Yeah.
Of course, this angle equals this angle too, but anyway, right? Yeah?
Mm-hmm.
Now you know BG divided by DF, right?
Yeah.
This BG divided by EF is equal to BG divided by EF equals to BOOF, right? Right? The BOOF here, you know, is 2.1, 2 over 1. So this is 2 over 1.
Okay.
Yeah. Now you look at this triangle and this triangle, because this is parallel. This is proportional to this, right?
Yeah.
And this is also 2 to 1. The sides is 2 to 1. Get it?
Mm-hmm.
AB, the same thing. AB divided by AE equals to 2 to 1, which is BG divided by ED, right?
Yeah.
Okay. Now look at this. Okay, let's find out this. Wait. BG divided by ED is 2 to 1. Yeah. Okay. Look at this term and this term. BG divided by DF this is all equal to 2. BG divided by EF equals BG divided by ED.
Yeah.
So BG. Wait a minute, that's the wrong one. Let's see. What I want to prove is that this equal to this, right? So GC, I need the GC here. BG divided by DF. Okay, let's look at this angle, this triangle. That'll work. It's through the DF.
Okay.
This triangle, you can get AC divided by AF, right? AC divided by AF. This is 2 to 1, right? You know it, right? You know the way you draw it. This is also equal to GC divided by DF.
Yeah.
Right? So now this is BG divided by EF. Right? That's equal to 2. This is GC divided by DF. That's copied wrong. Okay. BG divided by DF, right, equals to 2. Okay. GC divided by DF is also equal to 2. This is 2 equal, right? Then you go to BG equals to GC.
Yeah.
Right? You proved it, right? If you draw a line, this equals this. You look at this. Look at this situation, right? You have a triangle like this, right? This is a triangle. This is a triangle. These two triangles are similar. And then because they're similar, because this is equal to this equal to this, right? And the same angle, then you get this line parallel to this line. After this, all of these triangles are similar.
Yeah.
This triangle is similar to this triangle, right? Because they carry this line, so this is twice this.
Yeah.
Same. This triangle, let's see. We just did this triangle and this triangle, right? And then this triangle is equal to is similar to this triangle.
Yep.
And this triangle is similar to this triangle.
Yeah.
So all of these things, this is twice this, this is twice this. So everything, this equals to this. Actually, you don't have that. You don't have this equal to this. This equal to this. You can, in other words, this triangle is similar to this triangle, right?
Yeah.
Then you can get this part. This is half of this.
Yeah.
This triangle is similar to this triangle, right? Yeah. So this is half of this is half of this.
Yeah.
Right? Then when you look at this triangle and this triangle, right? Because they are similar too, and there's also 2 to 1, right? So this is also half of this.
Yeah.
That's how you prove that they're equal. In other words, you prove this thing is half of this and also half of this. This thing is half of this is through this triangle and this triangle, similarity. Okay? This is half of this is through this triangle and this triangle. That making sense?
Yeah.
Okay. This is how you prove things. Just to sort of recapture this business, you can write it clean.
Okay.
As a homework, right? You write it clean. You write it step by step, because of this step, you get that step, you get that step, whatever. You get to this. You draw some lines that doesn't belong.
Yeah.
To help you with the business. If you don't have this line, this is very hard, because all of these lines, there's no. You cannot hold on to anything. But if you draw this line, because this line is parallel to this line, then all kind of angles are equal, right? Yeah. When you have these two angles are the same, right?
Yeah.
Then this angle is obviously, of course, right? The opposing angles are a straight line. Of course, they're equal, right? Once you have this, you have all kind of equal angles here. That's what you're having here.
Yeah.
This angle equal to this angle. Everything is equal. From that, you can do any kind of business, and to get this similarity. What you get as a sort of a subsequent thing is, for this point, right? This point separate this line 2 to 1.
Yeah.
Yeah, this is 2. This is the odd one. This one actually we didn't prove, but this one we did prove. This is 2 to 1. This is 2 to 1. Yeah, because this triangle and this triangle. This is 2. This is 1. Right. So this is 2. This is 1. This is 2. This is 1. But this one doesn't have much use. Yeah. So this is 2. This is 1. All of these are properties in these triangles. Always. Doesn't matter how you draw up the triangle. Okay. Okay, that's line enough. We'll stop.